As a kid, I was obsessed with building roller coasters out of my favorite toy, Knex. My build started off very simple, but progressively they got more complex. That's when I started noticing a major flaw with the Knex coaster system though. These cars suck. To keep it simple, they create too much friction and wear down easily. One day the train would make it through the layout with ease. The next, it wouldn't even make it through the first element. I kept making coasters regardless though, but because of these issues I ended up cancelling way more projects than I finished. And when eventually, in the middle of constructing my best coaster yet, the train would stop making the layout, I quit. I was a devastated kid and didn't think I'd ever touch Knex again. That was until 10 years later, when I stumbled onto a video from the Knex maker. He upgraded his coaster cars with bearings and improved speed preservation tremendously. This inspired me to try to do the same with my trains. Could I finally build the coaster I dreamed of as a kid? The first step to building my dream coaster is improving the coaster cars. Sadly, I couldn't just steal the design that was already out there. It was made for the original style track, which is bigger than a micro track I built with. So I decided I'd finally make use of my years of studying mechanical engineering and design something myself. After a couple months of trial and error, I got to the design you see in front of you. The wheel assembly is heavily inspired by real life roller coaster cars. Each set of wheels has 2 wheels up top, 2 wheels on the side and a single upstop wheel to keep the car from flying off the track. Opposite sets of wheels are directly connected but can tilt independently from each other. The main advantage this 5-wheel assembly has over the 2-wheel assembly from micro coasters and the 3-wheel assembly from original coasters is that it keeps itself perfectly aligned and centered to the track. This is because the 2 top and side wheels steer the wheel assembly in the proper direction. This allows each wheel assembly in my design to be able to rotate independently from each other, which really helps the train get through sharp corners and twists without excess friction. Just like the wheel assemblies I was inspired by, mine use small bearings as wheels. These generate much less friction than the plastic wheels on regular Knex trains. The cars are connected via ball socket joints. This allows each car to move freely without interfering with the others. The body is a rough draft made to look like basic coaster seats. There are still lots of improvements to be made here in terms of looks, and I also need to find a way to add some more weight into the design. Right now I've just taped some steel balls to the body, which does improve performance but doesn't look very good. I'm fine with this right now, but I'll definitely improve the design for future projects. So consider subscribing if you want to see what I do with these cars next. Anyway, another thing to note about the bodies is that you can easily attach a chain dog to whichever car or cars you like. Everything except for the bearings and small bolts, nuts and washers is 3D printed on my Sovo SV06. Getting it to print these small parts accurately was quite a challenge, but luckily after a ton of trial and error I made it work. During the entire design process, I tested and compared my trains frequently against the stock Knex trains. Sadly, forgot to shoot a video of the final design on the test track, but here's a clip of an earlier prototype. It did much better than the Knex train. Much better. Now that I have a functional train, it's time to start building the coaster. For the layout, I had a couple requirements. Firstly, I wanted to get redemption for the final coaster I cancelled as a kid. This ride was inspired by Fahrenheit in Hersheypark and featured its signature vertical lift and Norwegian loop. So my new ride would have those too. My second requirement is that this coaster has to function as a good showcase of my 3D printer trains. So I incorporated a few elements that stock Knex cars would have really struggled with. Starting with a high-speed turn straight out of the Norwegian loop. This would normally be an absolute speed killer, so it's a great test for my train. Following the turn we go into a double corkscrew, again inspired by Fahrenheit. But instead of going straight from one corkscrew to the next, I've added a bunny hop in the middle. Again an element that could make or break my train design. In this element the train will get some airtime and thus shoot up against its upstop wheels. In order to have a smooth transition, the spacing between top and upstop wheel has to be perfect. After a double corkscrew, it goes into an upward helix made of curved track pieces. This will test how well the train deals with being under lateral Gs. After that, we got a couple twists and turns, back into the station and to lift. To do it all over again. Now that the track is finished, there's only one thing left to do.
Okay, let's go.
It worked, and after 10 years, I can finally sleep again at night.